and welcome back to CQ, the AWS Certification Quiz Show, where I'm here today to have another look at our essay exam with another essay, Luke. Luke, welcome to CQ. Tell everyone a bit about what you do here at AWS.
Thanks very much, MJ. So I'm a solutions architect at AWS. So what we try to do is make complex problems a little bit simpler, take away hard things, make things really a lot easier for our customers. That's the basis of it. There's a lot of technical stuff underneath, but that's the basis.
You made it sound very simple. I feel like it's not quite that simple.
There's a little bit, but yeah.
All right, why don't you give us a bit about projects that you're working on right now, Luke?
So we work on a lot of projects with different customers, but I would say one of the more fun ones we work on is machine learning projects. And one of my customers that I work with is Domino's, and we've done quite a few machine learning projects with that.
Nice.
So one of the ones which is really interesting I found is a thing called predictive ordering, where you can kind of use machine learning to tell whether an order is going to be finished, and then literally start sending or cooking the pizza and sending the pizza out before it's even finished. So I thought that was really cool.
Wow, that is cool. All right, tell us where we are today. Tell us a bit about our green screen.
Oh, yeah. So we're in the Great Barrier Reef right now. So I grew up in North Queensland.
New one for me, new one again.
Awesome. And yeah, so this is where I grew up. So I used to go diving as I was growing up as well. But one of the things that I noticed over the years is that, you know, there's a lot more focus on conservation efforts up there now. So that's something I'm really, really interested in.
And something you're concentrating on?
Yes.
Bit of a sneak peek for a question later maybe
yes,
that I might have in store for you. So you're ready to give our essay cert a go today with me?
All right.
Yeah?
Yeah, let's go.
Let's do it. Okay, question number 1. Let me bring it up for you. Here we go. So first one is on storage performance.
Okay.
So not the easiest way to go in actually, but we'll give it a go.
Yep.
All right, Luke, you are migrating a scientific application to run on Amazon EC2. The application frequently reads and writes multiple terabytes of temporary data to and from the disk. Okay. What type of storage can provide the highest performance random I/O?
Oh.
Wow, producer John has not gone easy on this first question with you.
Okay, so I'd have to try and start by pulling this apart. So I'd look really specifically at the EC2, running on EC2.
Okay.
Frequent reads and writes, so not just reads. Multiple terabytes. And the last part of it, I think it's really important that I like to look at is random I/O, because that's different to contiguous I/O, so that can affect the answer. So if we're going through maybe one, EFS. So EFS, I guess, so that's elastic file storage, but it's meant to be for a file system, an NFS file system.
Okay.
And so you're connecting that to your EC2 instance. So that could be it. It does take a bit of a latency hit when you use that though, so that may or may not be the one. Instant store with NVMe solid state drives. That's a nice one, which we might come back to. The reason why is because instant stores are really close to the server itself. Okay. And solid state drives are really quick. So I might have a look.
So like the look of that one.
Yeah, that's looking good. S3, using an Amazon EC2 instance type. Well, yeah, so basically what's happening there, I think that might be a bit of a distractor, that one.
Oh, you've been watching the show, Luke?
I have been watching I watched the show. So I think that might be a bit of a distractor because we're mixing up different services there. S3 is obviously an object storage service, and EC2 is well, we all know EC2. So it's something that are two different services altogether, so I wouldn't put them together in that sense.
Makes sense.
And EBS, okay, so that's another possibility. We'd have to basically work out the provision IOPS, and I do happen to know this because I did look this up a little while ago for a customer. Okay. So EBS is an attached storage. It is like something you attach to the EC2 instance, but the provision IOPS for that caps out. So it caps out at like 20,000 IOPS. Okay. So when you've got a cap, I'd be reluctant to sort of recommend it. So I'm pointing towards the instant store just because it's got a really low latency, really close. That's what I'm sort of thinking. We got a mix on the polls, but number 2 is just in the lead, actually. We'll see. Should we have a look? Yes, please. Reveal answer 1? Yeah. Oh, yeah, yes. Amazing. Do you feel a bit more relaxed now? Yeah, okay. All right, let's do it. Let's move on to number 2. RDS, all right. I reckon this might be a bit easier for you. Okay. Let's do it. So Luke, your application has a web server in a public subnet and an Amazon RDS database in a private subnet. The RDS database has been configured for automatic updates with a maintenance window specified.
What internet or network connectivity must you provide to enable the database update to successfully complete?
Okay, cool. So this is pretty
wordy,
and this is where you'd sort of pick it apart again. RDS, private subnet, configured for automatic updates in a maintenance window, so that's great. And then network connectivity, so they're the ones we're looking at. So the first one is placing a NAT gateway in the public subnet and update the route. You can do that. NAT gateways are there to do that, so they're there literally for patching. That's one of the reasons why we have that. The thing is, though, is generally we'd use a NAT gateway when we want to schedule patches ourselves. Okay. So if we built up EC2 instances our own infrastructure, we'd use a NAT gateway to do those patching. So that's an interesting one. Adding a VPC endpoint to RDS in the VPC, well, I don't think you can actually do that. There's a data API for it, but the VPC endpoint I don't think you can do for RDS, so that might be something. Setting the database to publicly available. Well, that is probably the one that I would never actually suggest. So basically security in AWS is, we used to say, is job zero.
Yeah.
If you ever see something that compromises security,
not going to be your answer.
Not going to be your answer. So I would say I would discount that one.
Yeah.
Okay, and no special connectivity required. That's a really, really good. I reckon that's one of the really good answers, and that could be a tip, I'd say.
Oh, really?
Yeah,
Is it time for tip of the week? Do you think?
I reckon that's probably a good one.
All right.
When we have managed services such as RDS, and you're looking at questions around that, what we like to say is the simplest is the best.
Is the best solution.
That's right. So particularly because we're making them for our customers, and we design our services for our customers.
Yeah.
So 90% of the services that we release are based on customer feedback, and it's really important that we get that right. So
that's why I like the look of number 4.
That's why I like the look of number 4.
As an overall tip for any AWS certification.
That's right.
Okay. Thanks.
So I'm going to go with 4, if that's all right.
Almost everyone on the poll has gone for number 4 as well.
Awesome.
Let's reveal the answer. 2 for 2. How are you feeling?
I'm good. About the next one coming up, but I'm good.
S3, you can't go wrong.
Cool,
Come on.
Yeah.
All right, let's do it. Your company serves thousands of static websites for people selling their homes. Your application architecture uses Amazon CloudFront in front of an Amazon S3 bucket. Okay. Each customer has their own subdirectory within the bucket. How would you modify this architecture to give each customer their own subdomain? And you've got an example there in front of you.
Okay, so 2 parts. Okay, so looking at thousands of static websites. And in that case, I'm obviously thinking about scaling, so being able to make it scale, any solution that I would do. Using CloudFront, using S3, and the customer having their own subdirectory within the bucket. So we like to look at what's currently there from an architecture point of view and try and work out the best solution based on the smallest amount of work, but also the simplest solution.
Okay.
And what we're wanting to do is slightly modify it to give each customer their own subdomain, right? Okay, so configure Amazon CloudFront with one origin per subdomain. Right, okay, so I can pretty much discount that one because...
So is all the online viewers.
Yeah, because there's a soft limit there, and that's 25 origins per subdomain, so I would discount that one. Number 2, Lambda at the edge. So for people who haven't seen Lambda at the edge, that's a small function that can be put literally running in CloudFront, and it can have anything in it whatsoever. But it gets access to the request and response data, so you can actually use that and modify it. And getting it and rewrite data too. So that's an interesting one that rewrites in there.
Yeah.
I like the look of that one, but we'll check just as we should. Add each subdomain as a new hosted zone in Route 53. So that'd be a lot of work, number 1. Number 2, it's a completely new hosted zone, and hosted zones do a lot. So I would probably not go with such a large change there. Change to using number 4, change to using one bucket per customer with the bucket name matching full. Okay, that's a similar problem to number 1. So we have a concept of soft and hard limits. It's probably come up before, I imagine. S3 has a soft limit of 100 buckets, but you can do a request to have that expanded up to 200 or something. But it does have a hard limit of 1,000.
Okay.
So if you're serving thousands of static websites, you're going to hit that hard limit doing number 4.
No, that's good to know. I don't think we've had that on the show yet, actually.
Okay, good.
So that's really cool.
So yeah, I'm thinking number 2 just because that's literally what Lambda at the Edge is meant to do. It's meant to rewrite requests to point to subdirectories, so I like the look of that one.
You've been edged out on the polls, Luke, with people favouring number 3.
Interesting. It is a valid solution. The reason why I would go with Lambda at the Edge is because it's less interference in the current architecture, and it's also, I think, more scalable because it's doing what Lambda at the Edge is meant to do.
Okay.
Whereas hosted zones are meant to be used like one per site. So
you sticking with number 2? Peer pressure.
You're making me doubt myself now. Yeah, I'll stick with number 2.
Yeah.
I'll stick with number 2.
All right, let's do it. Let's reveal the answer. Of course, it's Lambda at the Edge. Just breathe. Okay, You've got this. You've got this. All right, let's have a look at question number 4. And thanks to everyone in the chat saying, hey, really appreciate it. So let's have a look at decoupling, shall we?
Great.
An application sends messages to Amazon SQS for processing by AWS Elastic Beanstalk worker instances. You have been asked to modify the application architecture to also send the messages to an AWS Lambda function. Following? Still with me?
Yep.
How would you re-architect the system without modifying the workers?
Oh, okay. So pick out the services, SQS, Elastic Beanstalk, Lambda, cool. Key things in here, sends messages. Okay, messaging, we know what's messaging. Modify the application architecture, great, so I can modify it. But I like also send the messages. So I'm going to be doing something
keyword
at the same time, yeah. And the other thing is really key is without modifying the workers. That's something I'm going to be looking for as well. So
I like what you've done there. In each question, actually, you've just pinpointed the words that you want to concentrate on within the question.
Yeah,
okay.
So they're the things. So
just another tip.
Yeah, another tip.
While we're on.
So number 1, chain the AWS Lambda function to the end of the worker process. I guess what I was saying before, without modifying the workers, chaining the Lambda function to the end of the worker process is a modification of the workers. So I would be reluctant to do that. I mean, it would work, but there's other things that could go wrong in that as well. If you think about it, what if the worker process has an error, goes into an error state? Does the Lambda function never get called? You know what I mean? Like, that's not a good architectural principle. Also, there's a lot to that one, so I'm going to discount that one.
Okay. Don't get into the rabbit hole, Luke.
Yeah, I got to get out of that one. So redirect the messages to an Amazon SNS topic. Subscribe both the Amazon SQS queue and the AWS Lambda function to it. The good old fan out pattern. Yeah.
You got it.
Love it. Love the fan out. Big fan of the fan out pattern. So that's when you sort of, I think that this one is basically when you're sending messages 2 places. And the way you do that, we call that fan out as an architecture pattern. You got it? Yeah. And SNS is the perfect way to do that because it's a pub sub service, so subscribe. And you can have multiple things subscribing to that service. So that means that you can have the SQS queue and the Lambda function both subscribing to it, which is really, really good. So that's a really big contender. The Lambda function to call the workers after processing the message, that's the same as number 1. So you're chaining, instead of chaining the Lambda function to the end of the worker process, you're chaining the worker process to the end of the Lambda function. So that's the same. Migrate the worker instances to step functions to add a new step to send the messages to the AWS Lambda function. I love step functions, which I love it, and I really think it has a lot of great uses. But again, it's not fanning out, so I don't think that's the way to do it. So I'm going to go with 2 just because that looks like a great fit to the question.
And you got your first 100% agreeing with you on the poll as well.
Awesome.
Ready?
Yep.
Of course, it's number 2.
Good.
John loves that. That was going to be in there for you. All right, let's move on to question number 5. Sustainability. This is perfect for you, Luke.
I love this stuff. I just love it. This is going to be great. Yeah.
All right, let's get into it. Luke, your company has committed to improved sustainability by improving the environmental efficiency of their IT systems. How can the AWS Cloud assist customers in operating their IT infrastructure more efficiently? I'll just sit back.
Oh my goodness. So
This
talk
is all
about
you.
rabbit hole before. I'm going to have to stop myself from going down. So this is improve sustainability, improving the...
This is your speciality, right?
It is. It is. So it's sort of when it's, you know how when it's your specialty, you sort of like try and get your thoughts together and try and make it a bit clearer.
I mean, we only have a certain amount of time, so...
Yeah. So I'm going to try and do that. Cloud assist customers in operating their IT... Okay, so number one, improve capacity utilization by provisioning for actual loads rather than predicted peak loads. Absolutely. Yeah. Absolutely. So that's one of the clear benefits of the AWS cloud, any cloud for that matter. Capacity utilization is something that crosses over. Traditional data centers will often try to provision too much.
Everyone loving this answer so far as well.
Yeah. They try to provision too much. They try to just predict the peak load, and then you have to buy all the service for that. You may or may not ever hit that peak load. And as I'm looking at the second question, sharing capacity amongst multiple customers to avoid wasting power, that's a very similar response as well. And the cool thing about using the AWS cloud, particularly small constructs like, I guess, spot instances, is that any capacity that isn't currently being used, you can farm out via spot, which is really amazing. And so we can get even more utilization out of that than a traditional data center would have done. And the stats around this, you can see within traditional data centers, it's anywhere between 12 and 17% utilization, which is really low, right? You'd think that it'd be a bit higher than that. But this is based on the standardized research around traditional data centers.
Okay.
Now, the reason why cloud data centers are able to do that is through hyperscale and through capacity utilization, but they can achieve server utilization rates of around 65%, which is huge.
Wow.
So when you compare the two, it's pretty clear that those two are both right.
Okay.
So I'm just wondering about that.
Let's have a look at number 3.
Yeah, number 3. Reducing carbon footprint by reusing... Okay. So this is something we talk about a lot. So AWS has actually, and Amazon has actually committed to reducing its carbon footprint over the next few years. We actually did hit renewable energy, a 50% goal of renewable energy in 2018, so that's done. We're currently running on 50% renewable energy. By 2024, we've hit a goal, well, we're planning on a goal of 80% renewable energy, and by 2030, 100%.
Awesome.
So if that's one of the things you can, I guess, with the AWS cloud, we'll be always striving to reduce our carbon footprint. So number 3 is also right. And number 4, lowering power consumption due to Amazon's better PUE. Okay, so this is a good acronym to learn. PUE, power usage efficiency, or effectiveness actually, is something that is commonly used to measure data center performance from a power point of view.
Okay.
So it's the amount of data that comes into the data center versus the amount of data that is used specifically for servers, networking and storage. And then you divide that and you get a ratio.
Okay.
So a traditional data center has like a 1.7 PUE, whereas Amazon's data centers and cloud data centers in general, because of what we've been talking about before, hit a 1.2. So lower is better.
Okay.
So
okay. I think I'm following.
Yeah. So lowering power consumption due to Amazon's better power usage effect. Also true. So I'm trying to think where I would go with this one. I actually don't know if I can do anything else, but I actually can't pick a...
You like
one.
all the answers?
I like all of them for this, and I actually can't pick a clear one for it.
So you want to lock them in, all of them?
Is it like a trick question or something?
I don't know. Shall we reveal?
Am I supposed to choose one, or can I do all?
You're the guest. It's up to you.
I can't choose one.
You're choosing all of them?
I'm going to... I can't.
Or you're choosing none of them?
I'll just go with... I can't choose one. So let's go with all of them.
Oh, okay.
Yeah.
And it works!
Yeah, totally.
That producer, John. Such a trickster.
Thanks, John.
Also, this is just too easy for you, I feel. This was right up your alley.
Really?
Yeah.
Okay. Well, I reckon you should have a go at answering one of these questions.
Me?
Mm-hmm. Mm-hmm. If it's easy. And I reckon you know a lot more than you let on about this stuff. I reckon you do.
What is going on here?
Uh-huh. you reckon? What do you reckon, John? Do you reckon we can get like a switch over? We can switch our names over on the CQ.
Put MJ.
Yeah, put MJ as like the guest, and I'll do like the host, and I'll ask the questions.
Oh my goodness! What is going on here? I can see what's going on.
How do I do the intro? What do I do for the intro? Welcome to CQ. Okay, I'll try to do the intro.
Have you got the questions?
Okay. Okay. I'll do the question for you.
Oh my goodness.
All right.
But the next question was set up perfectly for you, Luke.
You want to do an intro?
Yeah.
CQ.
Okay, all professional.
This is a setup. Just to be clear.
Luke's the host.
Welcome to CQ, the AWS Certification and Quiz Show. I'm here with my special guest, MJ. MJ, would you like to try and answer a question for us?
Sure. Why not?
Amazing. Well, this question is on well-architected.
Hold on. So the solution architect is going to ask me a question on the well-architected framework.
I do reckon you know a bit more than you let on about this stuff. So we'll see how we go. You ready?
All right. Let's do it, Luke.
I'm ready. Which of the following is the design principle for operational excellence in the cloud?
No pressure.
No pressure.
Thanks, Luke. Thanks for having me
You're welcome.
on the show. Really appreciate it.
Yep.
All right, so well-architected. Here we go, to the solution architect. So well-architected is a framework here at AWS that helps architects and developers implement designs that scale over time. So our customers would use this mechanism to learn, improve, and measure their own architecture.
Awesome.
So within the well-architected framework, we actually have 5 design pillars. Okay, and you can see one of them here in the question. So operational excellence is one of those pillars. At the other bookend, you have security. And in between, you've got reliability, performance efficiency, and cost optimization. Did I get them right?
Absolutely. What do you even pay me for? Cool.
All right. So what is this question looking for? So we're looking for an architectural design within the operational excellence pillar. So let's have a look, shall we? This is so weird. This is so weird.
I love it.
Answer number 1. Review upcoming capacity requirements at monthly change advisory board meetings. Oh, good old CAVs, Luke. Here we go. So CAVs predate any, DevOps style practice. So I don't think this is going to be the answer. As that's actually rolled into the well-architected framework, which has made a move towards a more agile DevOps practice. So smaller incremental changes. And the word monthly doesn't really support that, I don't think. So if we're only releasing something monthly, what if within that release there's a multitude of updates?
Yep.
Within there, and one of those updates goes wrong. What does that mean? We would have to roll back that entire release and start again.
Yep.
So I'm not liking this answer at all, actually. So I'm going to get rid of number 1. So weird. I'm getting rid of the answer.
This is amazing.
All right, let's have a look at number 2. Update code repositories after every deployment. Okay, so no, so I don't like this answer either. So you would want that code commit done before deployment, so that you can redeploy or revert back to it later to that copy. Okay, so don't like this answer. Doesn't fit into that agile practice that we were talking about.
Okay, so scratch 2.
Yes. Let's have a look at number 3, shall we?
Yep.
Make frequent, small, reversible decisions. Okay, so this sounds perfect. Those are those smaller, quicker, incremental changes that I mentioned at the beginning. And actually, this is something here at AWS we call a two-way door decision.
Okay, yeah.
So look, that's that ability to reverse a decision, to back out of a decision when needed without repercussion. So something we would like, for example, if we had larger, fewer changes as per answer number 1, that's going to carry a bigger risk, and that's something we're trying to take away from our customers. Yeah. So I like number 3. I've never been able to say that before.
Amazing.
And number 4, enforce security on all infrastructure components. Okay, so real easy, the 5 pillars that I mentioned at the beginning, this one would fit into that security pillar.
Yep.
So I don't think this fits into operational excellence. And now actually, as I look at them, as I'm calming down a bit. 1, 2, and 4 are standard IT practices, whereas number 3 is that architectural design point. So I'm going to go with number 3.
Okay, what button do I press? How do I do this thing?
I'll just do that as well.
Okay, yeah.
Yeah.
Amazing. Well done, MJ.
How did the polls go on my question?
Okay, the polls are in total agreement with you, so there you go.
Oh, thank you.
Yeah.
Loyal viewers. I really appreciate that. Okay. So are we going back to you now for
No. I want to do this one as well. Can I do this one as well?
I better shut up.
No, can I?
Okay.
Okay,
right? Yeah, do it.
Oh, yes. Okay, cool.
Network design. I don't know about this network design.
Because networking's really easy, right? Okay.
Oh, gosh.
So a mining company operates IT and equipment in a location that is 2,000 miles from the nearest AWS region. A direct connection has already been provisioned. Okay. How would you architect the system to provide the lowest possible latency to an Amazon RDS database?
Okay. Why did I agree to this again?
This is so good.
All right, so I'm actually going to take one of Luke's tips from earlier in the day. I'm going to break down this really quite wordy question. So let's have a look at it, if you can bear with me. So we have a few services mentioned here. So AWS regions. A region is a specific, separate geographic area, and within that region, we have multiple isolated locations, our availability zones. What else? Oh, off the top of my head, 76 availability zones,
that's right.
24?
24 regions, that's it.
Thanks.
Awesome.
All right, so what else have we got mentioned here? Direct Connect. All right, so Direct Connect, or your DX connection, is your private dedicated connection network line between AWS and your premises.
Yep.
And we also have Amazon RDS, so your relational database service. Think of this as the power behind your mission critical apps. Really can't believe I'm saying this to you. It feels very weird. And RDS enables the customer to place their instances, in this case their database, in multiple locations.
Sure. Yeah.
So what is this question asking? So we're 2,000 miles from our nearest. Okay, so distance seems to be the problem. Obviously, distance is the main problem with latency. So this customer is far away from the region. They already have a DX connection, so don't think we're going to be looking to speed that up. And they want the lowest possible latency, so they want the most responsive connection. Okay, so when that is, how quickly is that database able to read requests?
Yeah, sure.
Is what we're looking for. So before I look at the answers, couple of things. So I mentioned the DX connection already being quite fast. So one way to improve that latency issue would be to speed up the line. I don't think that's where this question has taken us, because Direct Connect is already mentioned in the question.
Yeah.
So the other way to do it would be to bring the customer. Did I say something wrong?
No, this is amazing. It's like into your mind of how to answer a question. It's awesome. I love it.
Thanks. So the other way to do it would be to bring AWS and the customer site closer together.
Yeah.
So I'm thinking that's where the answers may be pointing us to.
Awesome.
Hopefully I'm right.
Awesome.
Obviously, I don't really feel like asking our customer to relocate closer to AWS. So I'm thinking it'll be something the other way around.
Sure.
So maybe local zones. Let's have a look.
Yeah.
Getting ahead of myself.
Yep.
All right, so number 1, implement a caching layer using Amazon Elasticache. Okay, so I don't think this is going to be the answer, but caching, obviously that's keeping our data in memory in RAM, which is much faster than going to disk or the database in this instance. I don't think this is going to be the answer. We don't seem to have enough info in the question that points to caching. You know, it doesn't mention anything about reads or writes. If the customer has a lot of reads, then caching would be good.
Absolutely.
If there was a lot of writes, then they're not going to benefit from a cache. So I'm going to get rid of number 1, I think.
Awesome.
Is that all right?
Absolutely.
What's the poll saying? I need to check in with my poll. Okay, good. They agree with me so far.
Polls agree. Yeah.
Let's check in on number 2. Activate Global Accelerator on the Direct Connect connection. Okay, I also don't think this is the answer for a couple of reasons. So firstly, Global Accelerator uses our global network to speed up between regions. Yeah. So this is not going to help the latency issue that the customer is wanting to fix here, because you'd still have to get to the region in the first place. Yep. So besides the point of the whole question. And also, Global Accelerator, Direct Connect, not compatible, because Global Accelerator provides its own fiber.
Yep, cool.
Getting rid of number 2 as
strategy,
well, I
yeah.
guess.
Awesome.
Forgot I hope I'm right. All right, number 3. Use AWS Outposts. Oh, okay, awesome. To provision a local Amazon RDS database. So I mentioned I was thinking it was trying to direct me to local zones initially, and local zones provide low latent access to apps locally, which is why I thought the question was pointing there, but I think there's only one in California.
That's right.
Wrong. So I wasn't leading the right way, but Outposts is perfect because Outposts takes that one step further, and Outposts actually puts a piece of AWS at the customer site locally. So what does that look like? So we would take a piece of equipment, so a rack, we'd place it at that customer site, enabling them with EC2 RDS. And it's really easy to use, accessed via the console as normal. So loving this answer so far. Outpost is built on AWS Nitro. It supports MySQL and PostgreSQL. And also, actually, another direct link to the question, it requires a direct connect or a DX connection. So I'm thinking this is exactly how we're going to get the most responsive connection possible, which is what the answer is looking for, what the question's looking for. But as per all certification questions, let's check in on number 4 just to make sure. Please. That's my tip of the week.
Tip of the week? Oh, can I do that?
No, you can't. Get off the bottom.
How do I do that?
Number 4, provision a database on AWS Snowball Edge. Awesome. So we actually saw an image of the Snowball Edge with Zoe last week, who didn't make me answer questions. Zoe, welcome back anytime. But Snowball Edge is not going to be the answer because 1, it's not compatible with RDS. But just as a reminder for our viewers, so Snowball Edge is a robust box that will physically transfer terabytes of data from the customer site to AWS into S3. So a really good way of transferring large amounts of data, not your quickest solution. And like I said, not going to be the answer here. Have I covered everything?
I'm bringing you as a specialist to all my customer meetings. I think you're good.
I don't think that's necessary, but I would like to lock in number 3, please, Luke.
Sure, okay, lock in number 3.
It's this button right here.
Button, look at this.
Oh,
yes,
thank
amazing.
goodness.
And the audience is agreeing with you as well.
Oh yeah, we didn't check on that.
Yeah,
Thank you very much.
Yeah.
I think we're done. I actually think we've gone over time, thanks to that putting me on the spot, Luke. Not sure you're going to be invited back.
It was a one-shot thing.
Thank you so much for giving me a chance. That actually felt really good to be in the other seat. So Luke, thank you so much
You're
for...
welcome.
Are you still hosting? Nah, I'll take over.
Yeah,
so thank you so much for joining us on CQ today. It was a pleasure to have you. And thank you all for watching. We will see you next week for another episode of CQ. Bye.